So looking at our objectives for today, we're going to learn how to describe patterns, and then we're going to write equations trying to model the patterns using a little bit of algebra, and that will then allow us to find any term in the pattern. That's known as the nth term. Find the nth term of the pattern. That's basically what we're going to be doing today. Nothing really crazy. But what is a pattern? So it's a repeat, right? Okay. So it's some repeating sequence. When we think about a pattern, that's a good way to define it. It's a repeating sequence. Well, what makes something a sequence? What makes a sequence different than just a list of random numbers? There's order to it. So all a sequence is an ordered list of numbers. So what I want you guys to do is I'm going to show you two patterns below, and I want you guys to describe to me what's happening. Because that, like I said, once you figure that out, the rest is actually just pretty easy. So you just got to figure out what's happening in the pattern. So we're looking at our first example. 27, 34, 41, 48. All right, so Taylor B. What's happening in that sequence? Okay, so say that again, Taylor. Here we go, we're increasing by 7. Right, so and that's the order. That's what makes this now a pattern. And so there's this order to it. We can see that we're increasing by 7 every single term. By the way, when we talk about terms, this is term 1, term 2, term 3, term 4. So what do we notice about terms? What makes something a term?
Position and place in the order.
Yes, the position in the order, right? We separate terms using which punctuation? Commas. All right, what about the next example? Okay, Lucas?
You divide by 3.
We're dividing by 3 every time. We're dividing by 3. So, put you guys on the spot here. So, Jay, I want to go back to my first sequence there, the 27, 34, 41, 48. What are the next 2 numbers in that sequence? So on this one right here, what would be my next 2 numbers?
55 and 62.
5 and 62, very good. Okay, Sam, what would be my next 2 on this sequence?
3 and 1.
What would come after 1? Caleb?
1/3.
1/3. What would come after 1/3?
1.
1/9. So you guys remember dividing by 3 is the same thing as multiplying by 1/3. So dividing by a number is the same thing as multiplying by its reciprocal. This is kind of leading us up into things. So, finding the next 2 terms is not a problem. And that's pretty easy. I think most of us should be able to be pretty successful at finding the next 2 terms. I think the trouble would be if I asked you to go find the 25th term. That would lead us into a bit of a problem, right? Because now that means we actually have to list this thing out 25 times. And what if I needed to know what the 131st term was? And I can even begin to imagine why you would need to know the 131st term. But if I asked you to find the 131st term, I would not expect you to sit there and list out that sequence, 131 terms to get there. So is there a faster way to do this? And this is what we're going to be talking about today with formulas. There are two types of formulas. One of them is recursive, and then the other one is explicit. In a recursive formula, we basically represent a term, represent the next term, based on the previous. And basically the terms is a sub n, where the n is the term number. So we look at our example up here, and we see a sub 5. What is that really asking me to find? Okay, if n represents the term number, what is a sub 5? So you good? Yeah, it's asking me to go find the fifth term of the sequence. That's what a sub 5 means. You might want to make a note of that in your notes. A sub 5 means the fifth term. A sub 10 means what? The 10th term. Okay, so the subscript is the term number. So if I have a sub 5, what's the previous term?
A sub 4.
A sub 4. But if I have the term a sub n, what's the term before a sub n? No. Okay. Chris, when I said a sub 5, and I asked for the previous term, you said a sub 4, how'd you come up with 4? So if it's a sub n, what's the term before a sub n? Well, it's what we have right here. Let's see if I can zoom here. A sub n minus 1. If I have a sub n for any number, the number before n is n minus 1. So your recursive pattern is always going to have this, or recursive formula, it's always going to have this n sub minus 1 in the subscript. Okay, it's always going to have that term as part of a sub n minus 1. And just it's learning how to speak to it and interpret what you're actually looking at. So here we go. We have our formula. Remember I told you that basically it represents the next term based on the previous term. So our next term is a sub n. And a sub n is the previous term, represented as a sub n minus 1. So the previous term plus 2. Okay, that's basically what we need to do. Well, look, it even tells you where to start. What's our first term? 2. If I want to find a sub 5, what do I actually have to find? In order to find a sub 5, I need to have what? I want to find the fifth term. I need to know what the, not only the first term, but the term before. I need to know what the fourth term was. But in order to find the fourth term, I need to know the third term, and then the second term. And so you guys can see where this is great if you have just a few terms to find. But in trying to find a sub 25 would not be useful. This would not be a great way to do that. But we'll kind of use the recursive here. So in order to find a sub 5, I actually have to list out all of my terms. So a sub 1 is 2. That was given to us. A sub 2, previous term, plus 2. So what's 2 plus 2? 4. A sub 3, 6. Previous term, plus 2. What about a sub 5 or a sub 4? 8. So finally we get down to a sub 5, which is Lucas.
Can you have this done 225?
Holy goodness, Lucas. Yes. Yes, you could have. What's important about that is that's two totally different ways of doing the same problem. We can have a recursive way of doing the problem, but as you just said, couldn't we have just multiplied and got it easier, faster, right? That leads us into the whole next thing. Again, if you're trying to find the 100th term, you don't want to list out all 100 numbers of that sequence.